Hello, this is Robert, and in this video I would like to discuss linked lists. I've created the framework for a very simple linked list program. There are no ADTs, no classes or anything like that, just a main function here, the node struct here, and then we have a function called add node. In main we have a variable set up so that the user can tell us which number they would like to add to our linked list. And we have a node pointer head right there that is set to null pointer. The node is set up right here, and inside of the node we have the data portion, which is an integer, and then we have a node pointer which is called next. It's very common to call this field link as well. So in the textbook it will be called link, but a lot of the examples on the internet use next. Okay, when we are creating linked lists, it's often very helpful to draw the situation that we have with our linked list so we can keep track of the state of our linked list when we're creating it. So let's take a look at my graphics program, and we'll see that we have a head pointer set up that is equal to null pointer. So here's my graphics program, and this is the memory for the pointer, and that slashing line through the middle of it means that it is set to null pointer. When we call the program add node, we're going to be passing the head pointer and the number that the user has specified. Let's just pretend that they type 5 for the number. So we're going to be passing the head pointer by reference to add node. We're passing the head pointer by reference so that we can modify the head pointer. So anything we do to h inside of the function add node is actually going to be modifying head, because that is the actual parameter right there. So h is a reference for head. Okay, when we call add node, we're passing in head and num, and we have a temporary node pointer in the add node function, which is local to the function. So let's draw that part. So here is our temporary pointer inside of add node. Well, in order to add the first node to a linked list, we need to create a node. So let's use that temporary node pointer to create it. Temp equals new node. Then let's fill in the data for the new node. Temp number equals num, and temp next equals null pointer. And with C++11 and compilers written after 2011, you can use null pointer. If you're using an older compiler, you need to use null, and they're basically interchangeable for the projects that we're creating. So if you prefer, you can use capital NULL instead of null pointer. Okay, now we have new memory set up for temp. So let's update our drawing for that. So here is our new node that temp is going to point at. So let's show that temp is pointing at that new node by drawing an arrow to it. Then we filled in the data, which was 5 for the number. Oops. There we go. And then we set the next field to null pointer, and let's signify that by putting a slash through it. So now our drawing reflects the same situation that we have in our code. Okay, so if this is the first node to be added to the linked list, then the head pointer should point to it. The way to find out if this is an empty linked list is to check to see if head is equal to null pointer. So let's put that check in our code. If head, or h in this instance, equals null pointer, then we know that this is the first node in the linked list. So this is the first node. All we have to do now is say that h equals temp. And then we have one node in our linked list. So h is a reference for head, so anything we do to h is going to modify the head pointer. The head pointer is no longer going to be set to null, so let's get rid of that slash, and then we'll specify that head and temp point to the same node by having head point to the same node that temp is pointing at. So when we said head equals temp, we set the value of this pointer here equal to the value of this pointer over there. Okay, and so we signify that, or we show that they're equal by having arrows pointing to the same memory location. After this function terminates, the temporary pointer will be removed from memory because temp is local, so this pointer will go away and we'll be left with a linked list with one node in it. Even though the temporary pointer was automatic and was deleted from memory when the function terminates, the node itself is persistent because it's on the heap. We're using dynamic memory, we're using new, so the node itself is not local to the add node function, it's on the heap, and so it persists. All right. That was pretty simple for adding the first node to our linked list. Let's go ahead and add another node to our linked list. So I'm just going to copy this code and ask the user what number they would like to add after the first one. So let's go ahead and grab those three statements. I'm going to yank them, and then I'm going to paste them after these. Okay. Looks like I have a leftover A right there. Oops, the A should have been right here. Okay, so now we're adding two numbers, and I pasted it to the wrong spot. Okay, that's more like it. So let's say that the user now wants to add a 7. So 7 will be the other node to be added to our linked list. The easiest way to add a new node to a linked list is to add it at the head. So let's go ahead and show how you can add new nodes to the front of the linked list. So when we call add node the second time, we're going to be passing in head and number. Now that we've added a node containing 5, head will no longer be equal to null pointer because we set h equal to new node in our function right here. So, or h equals temp. So now the head pointer is no longer equal to null pointer. So when we call this function, the if code right there, if the condition inside of the if statement is going to be false. So let's put an else right here. Else. So if we're going to be executing the code in the else block, that means that there is at least one node in the linked list. So we called add node again. So this is the second time we've called add node. So we created another temp pointer and we allocated new memory for the new node because this is the second time that we've called it, right? So let's go ahead and update our drawing so that we actually have another node and we'll use temp to point to it. Okay, so here's our next temporary node, and then we will set the value here to 7, and then we'll set the next field to null pointer. So this is going to be our temporary node for the second time we call the function. Let's make a little bit more room for it. So I'm going to move this up to over to here, and then I can move the temporary node up just a little bit. Okay, and this node is being kept track of with our temporary pointer. So let's have that memory right here. And so temp is pointing at our new node. So this will be the second node that we're adding to our linked list. So now our drawing is up to date with our code. In order to add the node that contains 7 to the front of the linked list, we need to have the next field point to the head node, and then we need to modify head so that it points to our temporary node. And then the new node will be added to the front of the linked list. So let's write the code for that. Temp next equals h. Okay, so let's update our drawing to reflect the fact that the next field inside of the temporary node is pointing at the first node in the linked list. So temp next equals h. Temp next equals h, or head. H is a reference for head. So now this field is pointing to the same place as the head node. Then all we have to do is modify the head pointer through h, the reference parameter, to have head point at temp. So let's update that code. H equals temp. And after that statement, our linked list is up to date. So head, or h, equals temp. So temp is pointing at this node. If we modify h to point at the same node as temp by saying head equals temp or h equals temp, they both point at the same node now. So now 7 is the first node in the linked list, and 5 is the last node in the linked list. And it's very important that the last node contain null pointer right there. So that slash signifies that we have a properly organized linked list. When the function terminates on line 25 right there, that will mean that the temporary pointer, which is a local variable, will go out of scope and will be removed from memory. So let's go ahead and update our code. This part will be removed from memory when the program terminates, and we'll have a linked list that looks like this. You can see that we can repeat this process over and over and over again and build our linked list from the head just by calling add node again. So let's just pretend that we add 3 to our linked list. So that the next time we call the function, we would create a temporary node, and then so let's go ahead and create that temporary node. And let's go ahead and put 3 in it. And then we would repeat the process of adding a new node, right? So we would say temp next equals h. So here's our temporary pointer again. So temp next equals h. So it would point over there. And then we would say, or I've already modified the head pointer, and then we would say h equals temp. And then this part basically goes away, so we would have an updated linked list. So I just threw that in there just to show that we could repeat this process over and over and over again and build the linked list to be as long as we want. So let's update our code so that we actually add a third node that contains 3. All I have to do is repeat the code that I have here on lines 33. 33 through 35. Okay, this time we will add a 3. Let's go ahead and add some code to print the list. So we'll add a new function, and then after that we'll add some code to free the memory so that we don't have any memory leaks. I'm going to pause the video for just a moment so that I can go ahead and set up those functions. Okay, I've written the code to print or list our linked list. This is the code right here. This is the function that's going to output the values of our linked list to the screen. Here's the call down here in the main function on line 46. So we're going to pass the head pointer to the function. This time it's not going to be a reference, it's just going to be passed by value. So node pointer h, so h is passed by value. The first thing we're going to do is set up a temporary node pointer called current, and so we're going to set that equal to head. Let's take a look at the situation as it stands right now when we call list. So we'll have our head pointer, or our h formal parameter that is pointing, it has the same value as head, and then we'll have current equals h. So we'll have 2 pointers pointing to the same memory location. Let's take a look at how that would appear in our drawing. So let's go ahead and modify this so that it says h, and it'll be a little bit more clear what we're talking about. This is the parameter that contains the same address as head. And then we created node pointer current, and we set that equal to h. So current and h are both pointing to the same node right here, the node that contains 3. So that's the situation that we have on line 27 right there. Then we're going to ask while current is not equal to null pointer. Anytime we have an arrow pointing at a node or at memory somewhere, that means that the pointer is not equal to null pointer. So our while loop is true. Current is not equal to null pointer. It's pointing at the first node. So we're going to enter our while loop, and we're going to output current number. So the value of our first node will be output to the screen. So the output will be 3. Let's just go ahead and place our output right here just to remind us what the output should look like. So the first number sent to the screen should be 3. Then what we're going to do is we're going to set the current pointer equal to the current next pointer. So this is called traversal. Current next is this field right there. So current is pointing at this node, and so this field right there, that is current next. Next is pointing over to this node, which is the second node in the linked list. So by saying current equals current next right there, we're going to have those 2 pointers point at the same location. So we're going to traverse to the next node in the linked list. So now current is going to point to the second node. So current was pointing here, current next is this field, it's pointing to the second node, so now current points there. That's called traversal. So we are traversing through our linked list. And then we reach the bottom of the while loop, and so we check our loop condition again. Well, current is pointing to the second node, so it's not equal to null pointer, so we will send 7 to the screen. So let's update our output right here. 7 goes to the screen. Then we traverse again and we set current equals current next. So let's update our current pointer to point to the next node. So current is pointing at the node that contains 7. This is the next field. The next field is pointing over to here. So if we set current equals current next, that means that this current pointer will point to the last node in the linked list. So then we'll output 5 to the screen because current is still not equal to the null pointer. So we'll output the value of the last node. So 3, 7, 5 will be output to the screen, and then we traverse one more time. Current equals current next. Well, when we do that, current next is equal to null pointer. So if we set current equal to current next, that means that current will be updated to be null pointer. So let's signify that by putting a slash through current, and then current will no longer be pointing at the last node. Current is null pointer. Current next was equal to the null pointer, so that's why current has been updated to be null pointer. So then we go around our loop one more time and we analyze our while loop condition. We discover that current is equal to null pointer, so the loop condition is false, and we're done listing the nodes in our linked list. Okay, I'm going to pause the video one more time so that I can set up the function to free the memory so we don't have any memory leaks. Okay, I've set up the function to free the memory so that we don't have any memory leaks, and I've called it free mem right there. And it's very similar to the list function that we created to print the values in the linked list. The difference here is that we are going to be deleting the nodes as we traverse through the linked list. So in a similar way to list, I've created current and I've set it equal to h, and then while current is not equal to null pointer. For this example though, or for this function, we need to keep track of the nodes and free them as we move down the linked list through traversal. And every time we move to a new node, we're going to delete it. So when this function starts, let's go ahead and take a look at what it would look like when we set current equal to h. Very similar to the way it looked when we started list. In this example though, we are going to set h equal to current next. So current is not equal to null pointer, so that's true. We're going to enter the code for the while loop. And the first thing we're going to do is we're going to move h to the next node. So we're going to traverse to the next node using h. So h equals current next. Let's set up that situation so that h is pointing to current next. This is h, this is current, and this right here is current next. So current next is pointing here. That means that h would point to the same place as current next. So now h and current next are both pointing to the second node. Now we are free to go ahead and delete the node that current is pointing at. So let's go ahead and take a look at that statement. So delete current on line 38 means the memory for the first node is going to be freed, removed from the heap. So that node is gone. So now we've reached the next statement, which is line 39, current equals h. So we're going to move current to point to the same node as h. So now current and h are both pointing to the same node. Then we repeat our loop. Current is not equal to null pointer, so we execute the code in the linked list again. H equals current next. So let's go ahead and move the whole thing over real quick. H equals current next, so now h is pointing to the last node in the linked list. Current next points to the node that contains 5. So H contains the same value as the next node, like that. So now we're free to delete current again, just like the statement in our code. So delete current right there on line 38. So we would get rid of this node. And then we would say current equals H, like that. Then we have H equals current next. So H gets the null pointer. So current next is set to null pointer, which means that H also contains the null pointer. And so because it's no longer pointing at anything, we can remove this arrow like that. So H is now set to null pointer because of the statement on line 37. So now we're free to delete current, and then current equals H. So if we delete current, that means we get rid of this node. And then we set current equal to H. So H is set to null pointer, which means current is going to be set to null pointer. Then we're going to go around our loop again, and we're going to check our loop condition. So now current and H are both set to null pointer. We're going to evaluate our loop condition one more time. Current not equal to null pointer. Well, current is equal to null pointer, so we stop our loop. And you might have noticed from the drawing that all of the nodes have been freed. So this is one way to free the memory in a linked list. Let's go ahead and run our code just to see if it works. And let's go ahead and call free mem right here. And then we'll build it. Okay, and now let's run it. So I think it was 7, 5, and 3, right? Or no, it was 5, 7, and 3. Okay, 3, 7, 5. So when we add nodes to the beginning of the list, they pile up at the front. So 5 was the first node, then we added 7 to the front, and then we added 3 to the front. So when we listed the values of the nodes, we got 3, 7, and 5. Okay, I hope this video was a good explanation of how to create a simple linked list. In my next video, I'm going to show you how to create a linked list using an ADT. So we'll use a class, and we'll use some member functions, and we'll make the data member a little bit more complex than just a simple integer. Okay, thanks for watching.